Alright guys, so today we will be doing area and perimeter. So a quick introduction. In today's lesson, we will be going over perimeter and area. This includes what it is, how it is used, and a few example and practice problems. So the first part of our lesson will be the basic concept of perimeter. So what even is perimeter? Perimeter represents the total distance on the outside of a two-dimensional shape or object. Two-dimensional means flat. It can be calculated by summing all the sides of the polygon. Shapes with curved edges have special ways of calculating perimeter, but shapes with straight edges are calculated normally. As we progress through the lesson, there may be patterns you start to recognize. This is because many of the shapes have the same side lengths. Because of this, I will briefly introduce some formulas that make calculating perimeter on certain shapes easy and efficient. So some shapes that I'll be going over are mainly squares and rectangles. So quickly, a square has 4 equal sides. This means that if you know one of the side lengths of a square, the remaining side lengths are all equal. A rectangle, on the other hand, has 2 pairs of equal sides. Opposite sides, like the top and the bottom, are equal, and the left and the right are also equal. Something quick, but what we will not be going over in this lesson, is an equilateral triangle, which is this. In an equilateral triangle, there are 3 equal sides. This means that this side length over here is equal to this side length, which is also equal to this side length. A is equal to B, and B is equal to C. So let's visualize it. Imagine you have a piece of paper, like this. You can see that the top of the paper is identical to the bottom. This is also true for the sides, left and right. If the top side of the rectangle measured 5 inches, this measured 5 inches, then so would the bottom. 5 plus 5 is 10. That means that the top and the bottom side lengths is equal to 10 inches. If the left side of the rectangle measured 3 inches, then so would the right. 3 plus 3 is 6. So when we add both side lengths, the sums, we get 6 plus 10. That is 16. Therefore, the perimeter of the rectangle is 16 inches. So let's watch a quick video on perimeter. This video will go more in depth with perimeter and give some good examples and very detailed explanations. Credits to Homeschool Pop for the video.
Okay, class, who would like to do problem 3 on the board? Please don't be me.
Today we're going to talk about the concept of perimeter. Alright, let's show you how fun this is. Imagine I'm a race car driver, right? And don't make fun of my car, okay? This is a perfectly good car to do a race in, right? It's very fast. It's got the bells, it's got the whistles. It's a great race car, okay? Stop laughing at it. Okay. Now imagine this is the race car course that I'm driving on, right? It's going around an oval. It's going around a shape. If I was wondering, how far is it around the track? What's the distance around the shape? Then I would need to know the perimeter. The perimeter is the distance around a shape. Wait. What is the perimeter? The perimeter of a shape is the distance around a shape. And it's easy to find. You can find the perimeter of a shape by adding all of the sides. That will tell you what the distance around the shape is. Great! Now let's practice finding the perimeter. Look at this triangle. What is the perimeter of this triangle? Okay, first we need to know how long all of the sides are, then we can figure out the perimeter. With this triangle, all three sides are the same length. So how long are they? Let's pretend we measured it, and each side is 10 centimeters. Now remember, to find the perimeter of a shape, we need to know the distance around the whole shape. So we just add the sides together. What's 10 plus 10 plus 10? That's 3 tens. What does that equal? Yeah, 30. Awesome. The perimeter of this triangle is 30 centimeters. Remember, cm is an abbreviation for centimeters. 30 centimeters is the perimeter of this triangle. Okay, let's try this one. What is the perimeter of this square? First, we need to know how long all the sides of the square are. Then we can figure out the perimeter of the square. Okay, so this is a square. It has 4 sides, and all 4 sides are the same size. Let's pretend we measured it, and each side is 1 yard. Remember, YD is an abbreviation for the distance of a yard. Each side is 1 yard. Remember, the perimeter is the distance around a shape, so we'll need to add all of these sides up. Okay, what's 1 plus 1 plus 1 plus 1? Yeah, 4. The perimeter of this square is 4 yards. The perimeter, remember, is the distance around a shape. If you were to go around this entire square, it would be 4 yards. Okay, this is the final one. What is the perimeter of this rectangle? Well, first we need to know how long all the sides of the rectangle are. Then we can figure out the perimeter. Remember, a rectangle has 4 sides, and 2 of the sides are shorter than the other 2 sides. With this rectangle, let's pretend we measured it at 1 meter on the short sides and 3 meters on the longer sides. Okay, remember, to get the perimeter, we have to add all of the sides together. So we're going to be adding 4 numbers together again. To make it easier, we're going to group the smaller numbers together and then put the larger numbers in our equation. What's 1 plus 1 plus 3 plus 3? Those are all the sides. What's 1 plus 1 plus 3 plus 3? Yeah, 8. Right, by adding all of the sides. And the perimeter of a shape is the distance around a shape. I'm so proud of you. I'm so proud of you. Now you know how to find the perimeter of something. The perimeter is the distance around a shape. I could find the perimeter of this tablet, right? All I would need to do is measure each side and add them together, and I would find the perimeter. But right now, I gotta find an internet connection. There's no Wi-Fi out here. There's no reason to be in the desert. I need water. This doesn't make any sense. Okay, so I'm gonna go. You go ahead and.
Alright, so that was just a more detailed explanation of perimeter. He gave some really good examples. So part 2 will just be practice and some formulas I will briefly explain. So in the next part of this lesson, we will go over some practice problems about perimeter and also introduce some important formulas that can make almost any perimeter calculation easy and smooth. So since it is a square, all sides are equal in length. A. A is just a substitute for the side length. So the perimeter, which is P, is equal to A plus A plus A plus A. P equals A plus A plus A plus A. That's the formula for the perimeter of a square. Now, since we have this formula, this will work for any, and I mean any values for a. Example, let's say a is equal to 3 units. That means a is equal to 3 units, a over here is equal to 3 units, a over here is equal to 3 units, and this a over here is equal to 3 units. Now we can substitute all these a's into the formula. 3 plus 3 plus 3 plus 3. That's just 3 times 4, which is 12. That means P is equal to 12, or the perimeter is equal to 12 units. So, let's start off simple, with a square. We know that a square has 4 equal sides. For example, let's say that one of its side lengths is 5. That means the rest of its side lengths are also 5. Look below. So here's our example square. Its side length is 5. Now we could just do 5 plus 5 plus 5 plus 5. That was the formula we saw back in here, in this slide. A plus A plus A plus A is 5 plus 5 plus 5 plus 5, because A, in this case, is 5. That gives us 20. But for bigger numbers, we can't just keep adding it. It'll get too complex. So we'll need a different formula. So another formula, and a better one, for the perimeter of a square is P, perimeter, is equal to 4s, where s is one of the side lengths. Now, if you think about it, a plus a plus a plus a is also equivalent to P equals 4s. I am interchanging s and a because they are variables. But 4s is 4 times s, which is basically adding s 4 times, or a. And this works because there are 4 side lengths of a square, and they are all the same. Therefore, we can just add 5 4 times, because there are 4 sides of a square, which is basically 5 times 4. Therefore, the perimeter of the square is 20. For smaller numbers, we can just use 5 plus 5 plus 5 plus 5. But for bigger numbers, we will have to use 4s, which is 4 times s, s being one of the side lengths. We can apply the same process to a rectangle, just slightly differently. As you can see, in a rectangle, opposite sides are congruent. Congruent means the same length. The longer side is always called the length, and the shorter side is always the width. This means that 8 is the length and 6 is the width. The symbol for the length is L, and the symbol for width is W. Therefore, the perimeter of a rectangle is 2L plus 2W. This is because these lengths, the top and the bottom, which are opposite sides, are the same. This also means that the left and the right, which are 6, is also the same. Therefore, we can just add these twice, or multiply them together, to get the perimeter. So if we substitute our values now, we will get 2 times 8, which is the length, and plus 2 times 6, which is the width. 2 times 8 is 16. When you add it to 2 times 6, which is 12, you get 16 plus 12. 16 plus 12 is 28. Therefore, the perimeter of this rectangle is 28. So here's a little more information. There are many other formulas for perimeter of different two-dimensional shapes, but squares and rectangles are the most common ones. So here's a quick video summarizing our square formula for perimeter. The last video we watched was just an intro. It didn't include actual formulas. This one will go over the perimeter of a square, the formula of it.
To start working smarter, not harder, this video is for you. As a pharmacy student, I had one exam at least every 2 weeks, not including.
Welcome to Math with Mr. J. In this video, I'm going to cover how to find the perimeter of a square. Now remember, perimeter is the distance around the outside of a shape. Let's jump into our examples, starting with number 1. So let's find the perimeter of this square, and we can do this by adding the lengths of all of the sides. Now for this square, each side is 8 inches. So we have 8 inches, 8 inches, 8 inches, and 8 inches. So perimeter equals 8 plus 8 plus 8 plus 8. 8 plus 8 is 16, plus 8 is 24, plus 8 is 32. So the perimeter is 32 inches. That's the distance around the outside of that square. Now I do want to mention, for squares, we can just multiply a side length by 4, since all of the sides are the same. Instead of 8 plus 8 plus 8 plus 8, we can just do 8 times 4. We get the same thing either way. So we can use the formula perimeter equals 4s, 4 times a side length. For this square, each side is 8 inches. So let's plug in 8 for s. So 4 times 8. 4 times 8 is 32. So the perimeter equals 32 inches that way as well. So for the perimeter of a square, we can either add all of the sides, or we can multiply a side length by 4. Either way will work. Let's move on to number 2, where we have a square with sides that are 11 meters. And you'll notice that we only have one side labeled. That's because this is a square and we know all of the sides are the same. So all of the sides are 11 meters. These tick marks right here show us that all of the sides are the same. We have one tick mark on each side, indicating that they are all, again, the same. They are all 11 meters. Then we have right angle symbols as well. Now, in case let's start by adding all of the sides. So we have perimeter equals, again, all of the sides are 11 meters. So 11 plus 11 plus 11 plus 11. 11 plus 11 is 22, plus 11 is 33, plus 11 is 44. So the perimeter is 44 meters. Now we can also find perimeter of a square by multiplying a side length by 4. So we can use the formula perimeter equals 4s. Let's plug in 11 for s. So 4 times 11. 4 times 11 gives us a perimeter of 44 meters that way as well. So again, we can find the perimeter of a square by either adding all of the side lengths, so all 4 sides, or we can multiply a side length by 4, since it's a square and all of the sides are the same. So there you have it. There's how to find the perimeter of a square. I hope that helped. Thanks so much for watching. Until next time.
Alright, so that was just a really good summary of the formulas we just went over, and some good example problems. So in the video we just watched, we learned that the formula for the perimeter of a square is P perimeter equals 4s. For the following problems, we will be practicing with rectangles. Because of this, I want you to know that the formula for the perimeter of a rectangle, that is P equals 2 times L plus W, where P is the perimeter, L is the length, and W is the width. Perimeter practice number 1. A rectangular backyard is 12 meters long and 8 meters wide. How much fencing is required to fully go around the backyard? The formula for the perimeter of a rectangle is 2 times L plus W. Let's input the values. L is 12, and W is 8. Now we can say that the perimeter of this rectangle is 2 times 12 plus 8. This because L from here is 12 and W from here is 8. That's how I got 2 times 12 plus 8. This is equal to 2 times 20, which is 40, because 20 plus 20 is 40. Therefore, the perimeter of the rectangle is 40 meters. Or, to answer the question precisely, you will need 40 meters of fencing to fully go around the backyard. So practice number 2 is a square. The question states, a square garden measures 9 feet on one of its sides. What is the perimeter of the garden? We learned that all sides of a square are equal. This means that the perimeter of a square is 4s, just like in the video we watched. If we even know one of the side lengths, we can calculate the perimeter. The question gives us 9 feet, but it's a square, so we know that 9 feet is on all sides. 4 times 9, from the formula, side length being 9, we get 4 times 9. This is equal to 36. Therefore, the perimeter of the square or garden is 36 feet. So, perimeter practice number 3. A rectangular running track is 25 meters long and 10 meters wide. If Jerry runs one lap around the track, how much meters did he run? So we have another rectangle here. Again, we can use the formula 2 times L plus W. In this case, the length is 25 and the width is 10. When we input these values into the formula, length 25, width 10, we get 2 times 25 plus 10. This is equal to 2 times 35. 35 plus 35 is 70. Therefore, the perimeter of the rectangle is 70 meters. Or to answer the question, Jerry ran 70 meters around the track. So the last part of our lesson will be area. In the final part of our lesson, we will be going over area. Don't worry, it's super easy. So what even is area? In simple terms, area is the measure of the two-dimensional or flat space occupied by a shape or surface, which is usually expressed in square units. With two-dimensional shapes, the total space occupied is called area, but for 3D or three-dimensional shapes, it is called volume. The formula for area is generally the same for all quadrilaterals, shapes with 4 sides. Video time. Here's a video that will go over what area is, as well as some real-world examples that will definitely give you a better understanding of what area is. The video will also go over the area of a triangle. Keep in mind that we will not be doing this, only rectangles and squares. Credits to Math Antics for
Want
the
to
video.
strengthen your math skills? Try Brilliant. It's an effective and fun way to learn, built for the way your mind.
Hi, welcome to Math Antics. In our last geometry video, we learned that all two-dimensional shapes have a one-dimensional quantity called perimeter, which is basically the outline of the shape. In this video, we're going to learn that these shapes also have a two-dimensional quantity called area. To help you understand what area is, let's start by imagining a line that's 1 centimeter long. Now, let's imagine moving that line in a perpendicular direction, a distance of 1 centimeter. But while we move it, it leaves a trail, almost like the end of a paintbrush. By moving the one-dimensional line that way, we formed a two-dimensional shape. And all of the space or surface that we covered along the way is the area of that shape, which, as you can see here, is just a square. Okay, but how much area does this square have? Well, our original line was 1 centimeter long, and we moved it a distance of 1 centimeter, so we could say that this shape is a square centimeter. Just like a centimeter is a basic unit for measuring length, a square centimeter is a basic unit for measuring area. But there's other units for area too. For example, instead of a centimeter, what if our line had been a meter long? And what if we had moved it 1 meter? The area we'd have gotten would be 1 square meter. Or what if our line was a mile long and we moved it a mile? We'd have a square mile of area. So just like with perimeter, the units of measurement are very important when we're talking about area. All right, so that gives you a good idea of what area is, but how do we calculate area mathematically? Well, there's some special math formulas or equations that we can use to find the area of different shapes. In this video, we're going to learn the formula for squares and rectangles and the formula for triangles. To find the area of any square or rectangle, all we have to do is multiply its two side dimensions together. They're usually called the length and the width. So the formula looks like this. Area equals length times width. But it's often written with just the first letters of each word as abbreviations. A for area, L for length, and W for width. So let's see if that formula works for our original square centimeter. If we multiply the length, 1 centimeter, times the width, 1 centimeter, what do we get? Well, 1 times 1 is just 1, but what about centimeter times centimeter? Centimeter times centimeter just gives us square centimeters, which we can write like this using a 2 as an exponent. We read this as centimeters squared, and it's just a shorter way of writing centimeter times centimeter. So whenever you see units like centimeters squared, or inches squared, or meters squared, or miles squared, you know it's a measurement of the two-dimensional quantity area. Okay, our formula, area equals length times width, worked for our square. Now let's see if it works for a rectangle. Here's a rectangle that's 4 centimeters wide and 2 centimeters long or tall. First, we plug the length and width into our formula, 2 centimeters and 4 centimeters. Then we just multiply. 2 times 4 equals 8, and centimeter times centimeter is centimeter squared. So according to our formula, the area of this rectangle is 8 centimeters squared. And we can see that's correct if we bring back our original square centimeter. If we make copies of it, you can see that exactly 8 of those square centimeters would be the same area as this rectangle. Great. Let's try our formula on one more rectangle. This rectangle is 2 centimeters long, but only half a centimeter wide. And our formula, area equals length times width, tells us that we just need to multiply these two sides together to get our area. 2 times 1/2 equals 1. So this rectangle is also 1 square centimeter. How could that be a square centimeter? It's not even a square. But just because a shape takes up 1 square centimeter of area, that doesn't mean it has to be a square shape. It just means that the total area would be equal or the same as a square centimeter. You can see that if we break up the rectangle in half and rearrange it, then it would form a square. In fact, we can use square units, like square centimeters, to measure any area, no matter what the shape is. It could be a rectangle, a triangle, a circle, or any other two-dimensional shape. Okay, now that you know how to find the area of any square or rectangle using our formula, we're going to learn the formula for finding the area of any triangle. But to do that, we're going to start with a rectangle again. What? The dimensions of this rectangle are 3 meters by 4 meters. So, what's its area? Well, using our formula, we know that the area would be 3 meters times 4 meters, which is exactly in half along a diagonal line from opposite corners. It forms 2 triangles. And because each of these triangles is exactly half of the rectangle, that means that the area of either triangle must be exactly half the area of the rectangle. We already calculated that the area of the entire rectangle is 12 meters squared. So the area of this triangle must be 6 meters squared, and the area of this triangle must be 6 meters squared, since 6 is half of 12. Aha! So the formula for the area of a triangle should just be half of a rectangle. So does that mean that instead of area equals length times width, it should be area equals 1/2 of length times width? Yep, that's basically it, but with one important difference. Instead of L for length and W for width, we're going to use 2 different names for our triangle's dimensions. We're going to call them base and height, and here's why. The names length and width worked okay for this right triangle, because the right triangle is exactly half of a rectangle. But those names don't really work for other kinds of triangles, like acute triangles or obtuse triangles, because how do you tell which side should be which? So for triangles, we do something different. First, we choose one of the three sides to be the base. It doesn't really matter which side you choose, and in a lot of math problems, the base will already be chosen for you. Once we decide which side the base is, we imagine setting the triangle down on the ground so that its base is flat on the ground, like this. Next, we find the highest point of the triangle, which is the vertex that's not touching the ground. From that point, we draw a line straight down to the ground. The line we draw must be perpendicular with the ground. The length of that line from the tip of the triangle to the ground is called the height of the triangle. Oh, some people call the height of a triangle the altitude, which makes a lot of sense if you pretend that your triangle is a tiny little mountain. Sometimes the height line is inside the triangle, like with an acute triangle. And sometimes it's outside the triangle, like with an obtuse triangle. And sometimes it lines up exactly with one of the triangle sides, like with right triangles. But no matter where it is, the formula for finding the area of any triangle is the same. Area equals 1/2 base times height. So if we know these two measurements, base and height, we can just plug them into our formula to calculate the area. At first, you might not see how the same formula could work for all three types of triangles, but watch this. Here's an acute triangle, and this box is 1/2 its base times its height. If we cut our triangle up, you can see that it fits perfectly inside that area. But wait, there's more. Here's an obtuse triangle with a box that's 1/2 its base times its height. Again, if we cut up the triangle, it fits perfectly inside the box. Now you can see how the formula, area equals 1/2 base times height, works for any kind of triangle. Okay, we already figured out that the area of this right triangle was 6 square meters. So let's practice using our new formula to calculate the area of these last two triangles. Our diagram shows that the base of this acute triangle is 5 meters and its height is 8 meters. So we plug those values into our formula for area and we get area equals 1/2 of 5 times 8. 5 times 8 is 40, 20 meters squared. Let's try our last example. We end up with the equation area equals 1/2 of 4 times 7. 4 times 7 would be 28, and then we can calculate what 1/2 of 28 would be by dividing by 2. 28 divided by 2 is 14. So the area of this obtuse triangle must be 14 square inches. A two-dimensional quantity that area equals length times width, and you've learned the formula for calculating the area of any triangle. Area equals 1/2 of base times height. But don't forget to practice what you've learned by working some problems on your own. That's how you really get good at math. As always,
Really good video on area. So in the video, we learned that the formula for area of a rectangle is A equals L times W, where A is the area, L is the length, and W is the width. We also learned that the formula for the area of a square is A equals S times S, or A equals S squared. We also learned about a triangle, but we will not be going over that in today's lesson. So here's an example problem and practice problem for area. A school is constructing a classroom. They know that the total ground cover of the floor is 300 square feet. They also know that the width of the classroom is 15 feet. Given the area and asked to find the length, instead of given both the width and the length and asked to find the area. First, we must always write the formula, no matter what values we are given. It is A equals L times W, which is basically area equals length times width. Variables can sometimes get confusing, so it is always important to, if you don't understand them, write it in word form, which you can understand. Now, since we have our formula, we can just plug in the values we already have. The area is 300, and we know that the width is 15. This means that our formula now becomes 300 equals L times 15, or 15L. Now, I know I've done this a lot, so it is important to note the values that are together, like 15L, and I say together because with 15L, it is two different values. There's not a space in between. So if this is the case for anything like this, it means 15 times L. Two values stuck together means multiplication. Since we have this equation, we can divide 15 on both sides. Let me draw something that will help. Alright, so we have 300 equals 15L. So we can divide 15 on both sides. Now, since we have 15 on the numerator, 15 on the denominator, like we learned in fractions, it can cancel out. This leaves L. So L, or length, is equal to 300 divided by 15. This value, I'll just do quickly for you, is 20. Therefore, the length of the classroom is 20 feet. So, it's time for your homework challenge. So for this week's homework, you can design your own room. It can be a square or a rectangle. There are a few guidelines you must follow. So here they are. Your room or rooms must have 2 or more rooms, like a bedroom, kitchen, and bathroom. It must be unique. Don't generalize it, so you can do what you like. At the end, you need to assign length and width values for all your rooms. Then, calculate both area and perimeter for them. Make all your rooms in two-dimensional format, which is flat on the paper. This is so that you can easily calculate the area and perimeter. And most importantly, have fun while you're doing this homework. Alright guys, thanks for listening, and I hope you learned a lot in today's lesson. See you next time.